Hi everyone, welcome to my channel. This is Quantum Unicorn. The LeetCode problem we are solving in this video is rotate array. So given an integer array nums, rotate the array to the right by k steps, and where k is non-negative. Okay, well, let's take some time to understand the intuition behind this solution. First, we need to calculate the effective number of steps k by taking the modulus of k with the length of the array nums. This adjustment ensures that k is within the range of valid rotations. And then we reverse the entire array nums using the reverse method. This action flips the order of elements, effectively rotating them in the opposite direction. And then we reverse the first k elements of the array by assigning the reversed values to the corresponding elements using the slice syntax. And this step ensures that the first k elements are now properly rotated. And lastly, we reverse the remaining elements of the array by assigning the reversed values to the corresponding elements using the slice syntax. These steps ensures that the elements after index k are correctly rotated. By performing these three steps, the code achieves the desired rotation of the array nums to the right by k steps. The underlying logic of the code is based on the observation that reversing the array effectively rotates the elements in the opposite direction. And by reversing specific portions of the array, which are the first k elements, and then the remaining elements, the code achieves the desired rotation effect. I hope this analysis will help you comprehend the reasoning behind the code and how it achieves the required rotation of the array. Now, let's break down the code for the rotate array problem and understand its syntax, mechanism, algorithm, semantics, and logic. First, the code defines a class solution that contains a method rotate. This is the solution method for the rotate array problem. And the method takes two parameters, nums, which is the input array of integers, and k, which is the number of steps to rotate array. The return type specified as num in the method signature indicates that the method does not return any value explicitly. Instead, it modifies the input array nums in place to achieve the desired rotation. In Python, functions and methods can have a return type annotation to indicate the expected type of the return value. Specifying num as the return type means that the method does not produce any specific output. Okay, now let's understand the steps performed in the code. The first line adjusts the value of k to ensure it is within the range of valid rotations. If k is larger than the length of the array, it takes the modulus to find the effective number of steps needed. And this line reverses the entire nums array using the reverse method. By reversing the array, the elements are rotated in the opposite direction by k steps. And then we use the third line to reverse the first k elements of the array. The code uses the reversed function to create a reversed iterator, and the slice syntax assigns the reversed values to the corresponding elements. And the last line of code reverses the remaining elements of the array, starting from index k to the end. It follows the same approach as the previous line, using the reversed function and the slice syntax to assign the reversed values. The overall logic of the code is to perform 3 reversals on different portions of the array. First, the entire array, then the first k elements, and finally, the remaining elements. This sequence of reversals achieves the desired rotation effect. And by following this approach, the code efficiently rotates the array to the right by k steps in place. The space complexity of the given code here is O of n, which is constant space complexity. And because the space usage does not depend on the input size, but remains constant throughout the execution of the code, the modifications are done in place on the nums list without using any additional data structures that grow with the input size. The time complexity of the code is O of n, where n is the length of the nums list. This is because the code performs 3 reverse operations on different parts of the list, each taking linear time proportional to the size of the corresponding subarray. Alright, that's all for today. I hope this was helpful. If you have any questions, please leave a comment. And also, please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.